Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 14th, 2025, about 3 days ago. This paper shows that ONELIFE learns an interpretable symbolic world model from a single unguided episode and outperforms a strong baseline, with MRR of 0.479 versus 0.351, a delta of 0.128, and a rank at 1 gain of 7.9 percentage points. The paper is titled, ONELIFE to Learn, Inferring Symbolic World Models for Stochastic Environments from Unguided Exploration. And, as we will see later, the implications for data efficiency are significant. It also cuts edit distance to about 8.76 from 10.63 and 0.058 from 0.071, and its imagined rollouts correctly rank plans in all 3 tested scenarios. Alright, the previous segment introduced the one-episode learning goal. Figure 1 illustrates how ONELIFE closes the loop. The world learner interacts for a single episode, collects observations with no rewards, and then synthesizes symbolic world laws with precondition and effect code. The right panels show probabilistic beliefs over a zombie's next move, which captures stochastic dynamics. The benefits bar indicates a roughly 70% win rate over 23 mechanics versus about 30% for the baseline. So Figure 1 showed the one-episode loop. Figure 2 illustrates how learning happens through a dynamic computation graph that activates only the laws whose preconditions hold. The player movement and zombie movement laws explain the observed transition, while the inventory update law stays inactive, so only their weights get updated. The loss aggregates opinions over observables like player position and zombie position, which are modeled as discrete distributions. The data panel provides the single transition that drives these updates. Okay, Figure 3 defines 2 metrics for judging the learned world model. The left panel illustrates state ranking, where a ground truth next state competes with many mutated distractors, and the model earns credit by assigning a higher rank to the real state. The right panel explains state fidelity, which computes an edit distance between the predicted next state and the ground truth. A toy example shows 1 minus 2 common over 3 total equals about 0.33. So, the previous figure defined the metrics. Table 1 reports results averaged over 10 trials, where all methods share exploration and law synthesis, but differ in parameter inference. ONELIFE reaches rank at 1 of 18.7%, and MRR of 0.479, improving over PoE world by 7.9 percentage points and 0.128. State fidelity stays competitive, with raw edit distance about 8.76 versus 10.63 and normalized 0.058 versus 0.071. The random baseline, shaded gray, performs poorly. So while Table 1 summarized overall gains, Figure 4 breaks performance down by scenario. The bar chart groups tasks by core mechanics, and the blue bars for ONELIFE generally stand taller than the red bars for PoE world. The dashed blue average line also sits above the dotted red line, which signals a higher mean reciprocal rank across groups. Overall, the model wins in most of the 23 scenarios, showing a broader grasp of environment rules. Alright, the previous figure showed per scenario accuracy. Table 2 presents planning via forward simulation, where 2 coded plans compete in 3 scenarios, and the learned world model ranks them by predicted reward. The model matches the ground truth preference in all cases, which signals it captures causally relevant dynamics over long, 30-plus step chains. Examples include crafting a sword before fighting for higher damage, mining only after crafting a pickaxe, and reusing a single crafting table to save wood. Wrapping up, 2 takeaways stand out. First, modular precondition and effect laws let a single unguided episode yield an accurate, interpretable world model. Second, the learned model supports planning over long horizons, not just prediction. The broader implication is data-efficient, transparent agents for messy stochastic worlds. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.